Couple more questions on circle theorems, and on this question we're actually asked to prove one of them. To start with, let's draw a construction line that will help us, and it's going to be this line here. And it's another radius. And I think it's also a good idea to mark all the radii on the diagram. Now, by putting that construction line in, the line OB, there's nothing to say that this angle here equals this angle here. There's nothing to say we've bisected the angle ABC. So let's call this angle X, and let's call this angle Y. Now, where can we put other angles X and Y? Well, first of all, look at triangle OBA. It's an isosceles triangle because we've got the two radii spurs, like the spokes of a bicycle wheel. We've got two spokes here. So there's another angle X sitting down here. So sticking with this triangle, this angle up here, which is angle BOA, is equal to 180 minus 2x, because the angles in triangle BAO must add up to 180 degrees. So we can now do a similar job on triangle BOC, and we can say a very similar statement about the angle at the top of the triangle, this angle here. So let's call this angle, the remaining angle in the circle, let's call that Z. Now, all those angles do lie on a circle. So what we can say is that Z plus this angle, which is 180, minus 2x, plus this angle, which is BOC, which is 180 minus 2y, must equal 360. Now, 180 plus 180, so we've got 360 on this side, and we've also got 360 on this side. So these will all cancel. So what have we got after all that carnage? We've got that Z minus 2x minus 2y is equal to 0. Therefore, putting the 2x and the 2y on the other side, Z is equal to 2, taking the common factor out, x plus y. Well, look at what we've done. We've now said that this angle here is 2x plus y. Well, that is exactly double what the angle ABC is. So I can write my conclusion up here. I can say that therefore Z, which equals 2x plus y, is also 2 times the angle ABC. This is proved as required, and that is your proof.